Hey 8th grade, we're going to go ahead and finish up section 2 of chapter 6. This is where you are going to need your cutouts. So if you have not yet printed them out, go ahead, pause the video and do that now. The first one we're going to do, actually let me get situated here. Oops, sorry, I'm going to put a letter A. And this, where it says snack bar, is the first one that we're going to work on. So pause the video and go ahead and glue that in. Alright, I have mine glued in. I'm going to go ahead and read it. And from this, we are going to make two linear equations. And we're going to use substitution in order to help us solve this. So it says a snack bar sells two sizes of snack packs. A large snack pack is $5. A small snack pack is $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many snack packs did the snack bar sell? Alright, so before we even get started, I'm going to go ahead and use two variables to represent the two different things that I'm talking about, large snack pack and small snack pack. I'm going to use L, and I'm actually going to write it as a cursive L so I don't confuse it for a 1. I'm going to use L to mean the number of large snack packs. And I will use an S to represent the number of small snack packs. Okay. If you have a situation like this, your equations are going to be set up two ways. There's going to be one equation that represents the total number of snack packs you have, and one that only talks about the money. So I'm going to use these two lines to write my equations. This one's going to be number of, I'm just going to put packs because I didn't put enough space there, meaning snack packs. And this one is just going to be about money. This is going to help you set them up in the future because you're going to see a lot of them that kind of follow this same pattern here. Alright, so let's do this first one that only talks about the number of packs sold. So it says in one day the snack bar sold 60 snack packs. That means however many I have of the large ones and however many I have of the small ones, if I add them together, then I'm going to get 60. So this one's going to be L plus S equals 60. So this one only deals with the number of packs that are sold. The next one's going to deal all about the money. So it says that a large one costs $5 and a small one costs $3, and altogether they sold $220 during that day. So however many large ones I sold, I know that it was $5 for each one, so it's $5 for each one. And then the small one was $3 for each one. And if I added these together, that gives me $220. So those are my two equations. Now you notice that I don't have a variable isolated for either one of these. So I'm going to take one of my equations and get one of the variables, either L for large or S for small, by itself. Doesn't matter which one you want to solve for because you'll end up solving for both of them at the end anyway. I'm going to use this first one because neither the L or the S have coefficients in front of them. And I'm going to get L by itself. So I'm just going to rewrite it down here. L plus S gave me 60, which means that L would equal 60 minus S. You could also write, you could also write this as negative S plus 60. It would be the same thing. So what I'm going to do now is take this and plug this into my other equation where L goes. Stop moving. There we go. So instead of 5 times L, it's going to be 5 times 60 minus S. plus 3s equals 220. Okay, so now distribute 300 minus 5s plus 3s equals 220. I'm going to combine like terms here, so 300 minus 2s equals 220. I know it's negative right now. Don't freak out. It's going to all resolve itself in just a second. I'm going to subtract 300 from both sides. I get negative 2s equals, this would be negative 80. Okay, divide negative 2, divide negative 2. I get that s equals 40. Okay, so of the small snack packs, I know that they sold 40. So what I'm going to do now is take that 40 and plug it into one of my equations to figure out, well, how many large ones did they sell? And I'm going to use, just going to scoot this up a bit. I'm going to use this first one because I don't have to multiply anything. It's going to be easy for me to figure out how many large ones that they used. So I'm going to use that first one. It was the large plus the small equaled 60, but instead of s, I'm going to plug in 40. So that means that I had to sell 20 of, let me scroll that down, 20 of the large ones. And let's just make sure that that makes sense for the other one as well. If I plugged in 20 here, okay, 5 times 20, that would give me 100. 3 times 40, that would give me 120. Yep, 100 plus 120 would equal 220. So they sold, and I'm just going to kind of write this as a sentence. They sold 40 small packs, snack packs, sorry, 40 small snack packs and 20 large ones. That is the number of each one that they sold. Well, let's go ahead and try another. I'm going to go to the top of a new page. Sorry that these take up so much room. There's just a lot of work that goes along with them. I'm going to put a letter B, and I'm going to glue in this next one. What I'd like you to do right now is pause the video, give it a try yourself, and then hit play to see if my work matches yours. Alright, so the first thing I'm going to do is go ahead and define the variables that I see here. Actually, I should probably read the problem first. That's a good idea. You pay $22 to rent 6 video games. The store charges $4 for new games and $2 for older games. How many new games did you rent? Okay, so I'm going to go N to be the number of new games. And I'll write a cursive O, just so I don't confuse it with the 0. Cursive O to equal the number of older games. Okay. And remember, you're going to have 2 different kinds of equations. One to represent just the number of games, and the other one that deals with solely the money. So the first one should look like this. However many new games you rented, however many old games you rented, that would be 6 games altogether. And however many new games, well, each of them are going to cost $4. The old games are each going to cost $2, and altogether you spent $22. So you're going to take one of your equations and you are going to isolate one of the variables. I'm going to use the first one just because there's no coefficients in front of the n or the o. It's going to be really easy to solve. So if I wanted to get n by itself, I would subtract o from both sides. So if I rewrote this problem, it would be n equals 6 minus o. So now what I'm going to do is take this piece and plug it into my other equation where n is. So instead of 4 times n, it's going to be 4 times 6 minus o plus 2o equals 22. Go ahead and distribute. You get 24 minus 4o plus 2o equals 22. Scroll down a little bit. There we go. 24, I'm going to combine like terms, minus 2o equals 22. Subtract 24, subtract 24, negative 2o equals negative 2. I divide by negative 2 on both sides, and I get that o equals 1. So it looks like I rented just one old game. So what I need to do is take 1 and plug it back into my other equation and see how many new games I rented. And the easiest one to do is probably the first one because I don't have to multiply anything. So instead of n plus o equals 6, I'm going to do n plus 1 equals 6, which means that n has to be 5. And let's make sure that that is true. If I plug in, for the other one, if I plug in 5 for n, I would get 20 plus plug in 1, I would get 2. Yep, that would equal 22. So I know that my two answers are correct. So I'm just going to write this kind of out as a sentence. I purchased or rented? Sorry, rented one older game and 5 new games. Awesome. All right. So that is how you use substitution in order to help you out with word problems. All right, we're going to do one last thing, and that has to do with linear equations that have infinitely many or no solutions. So I'm going to hop to the top of the next page, and I think I'm on 4. Yes, this is 4. And turn that a little bit. There we go. All right, so we're going to be talking about infinitely many solutions and no solution. Okay. So I'm going to put a letter A, and I'm going to write out these two equations. I have x equals negative 2y plus 4 and 3.5 x plus 7y equals 14. Okay. So one of my equations, this one, is already solved for one of my variables. I already have a variable by itself, so I can take what is on this side of the equation and plug it in. So this would give me 3.5 times negative 2y plus 4 plus 7y equals 14. I would distribute, and I would get negative 7y plus 14 plus 7y equals 14. I'm going to combine like terms. If I have negative 7y and positive 7y, these actually cancel each other out. So I'm left with 14 on one side and 14 on the other. If you solve any sort of equation and you end up with one number and the exact same number on the other, this is always, always, always true. So this is going to be infinitely many solutions. Why? Because these two lines, if I were to solve them and make them both look like y equals mx plus b, they'd end up being the same line. So these are the same line. If I were to graph them both on a coordinate plane, they would line up perfectly with each other. Let's try another one. All right. Let's do y equals 3x minus 11 and y minus 3x equals negative 13. Now, one of my equations, this one here, is already solved for one of my variables. I've got y by itself. So I'm going to take what's on this side of the equation and plug it in where y goes. So I would get 3x minus 11 in place for y. Minus 3x equals negative 13. I'm going to combine like terms. I have 3x and negative 3x, so these guys actually cancel each other out. So on this side of the equation, I have negative 11 equals negative 13. If you solve any sort of equation and you get one number equaling a totally different number, which is never possible, this can never, ever, ever be true. So this is no solution. Why? Because these are parallel. If I were to graph these on a coordinate plane, they would be parallel to each other. They're never going to intersect. Remember, the solution that we find is really where do these two lines intersect? Where do they cross over each other? If they never cross over each other, there's never going to be a solution. Alright, so go ahead and stop the video there. I'm going to have you hop on over to IXL and practice these skills there.